So first thing I wanted to show you is just what we're looking at here. I have set up an actual multi-tier deployment here. I have an E40 where most of the tapping is occurring. I have an E100 that's doing a mid-tier aggregation, and a Vision 1, which is where the intelligence and packet grooming is occurring. And you can see I have 80 gig interconnects connected between each of these to carry what my anticipated load will be. The first thing to note as we look at a diagram view of this is, first of all of the ports that, irrespective of where they physically reside, are available to me here. On a single pane of glass, I have access to everything. And I can take any of those and use those for observed data, or what we call network ports, or any of those and use those for tool ports. What we're seeing here is actually a number of taps that we have flowing into an aggregation point or dynamic filter, and then being sent off to two locations. So we're seeing replication here that we talked about in the NetStack, those table stack features. And then we're going to talk a little bit more about the advanced features as well. It should be noticed that, with proper naming conventions, as we talked about, it's very easy for me. I could have opened this up 6 months ago and come into it now and see very easily what's going on in terms of where data is coming from, spine A to leaf 1, side A, and so on, and where I'm sending it to. In this scenario, as far as adding additional segments, I have a couple of segments that I've tapped that I want to add into this aggregation mix, and that's really just as simple as, connecting that data to the aggregation point or dynamic filter, which I've done by dragging here. I also have the ability, if, let's say I added 15 of these and I didn't want to, connect them all one by each, I can do that within the Connections tab as well very, very easily. Now you'll notice that I have packet stack resources applied here, and I want to talk a little bit more to that. We talked about FPGA and the packet stack features being enabled through FPGA. So in this case, the Vision 1 has a max capability of 160 gig of packet stack resources. And what I did was decided, based on the total amount of aggregate data I expect from all of these ingress sources, a max of 60 gig. And that ensures that for packet processing purposes, I can use all of these features where it makes sense, obviously, interchangeably. I can strip, I can trim, probably wouldn't make sense to do both of those in the same operation, but, in this case, what I want to do is focus more in on deduplication. In this case, we're doing time-based deduplication and looking at all packets that arrive within 500 microseconds. And it's important to point out that we have the ability to fine-tune this as well. Right now, I'm not ignoring any of the header, but I could choose to ignore the MAC or ignore all the way up to layer 3, as well as MPLS, as far as making a determination as to whether it's a duplicate or not. Okay, and just to look at what's going on there, if we look at statistics on this resource, what you'll notice is that, again, we're kind of displaying stats around all of the features, but what you can see with the one that we have enabled is that we're removing approximately 30% of the packets, which are duplicate packets, that are not being forwarded to the tool and not taking up CPU resources to eliminate. Okay.
Yeah.
Go ahead, Tim.
One thing to add there, you mentioned that 160 gig capability for packet stack on the Vision 1. With this 40, 100 gig discussion, there are probably some users out there that need maybe a lot more than that. That Vision X platform that you saw on a previous slide, that can do up to 2 terabits in a single platform.
Right. So definitely, as Tim mentioned, the further right you went on the slide showing the packet brokers, the more capabilities that you had. And one other note is that we're completely transparent. You saw me bring up statistics before, but just to look at the statistics on the tool port, you can see right now that approximately 18 gig is hitting that tool port. So I'm not in danger of, you know, overloading this 40 gig connection to the tool currently. But if anything were to occur, we will tell you immediately when that happens. You can actually set up alarms for that as well. The user interface will show it with an exclamation point here as well. Then it becomes very simple to address, provided that you have tool interfaces available. I could simply create a port group by adding another 40 gig port to the existing 40 gig port, and then we will load balance across those two interfaces using session affinity, ensuring that all the packets associated with a given session are sent through a given side of that 40 gig connection, or 80 gig connection. We talked a little bit about intersection mode. Okay, I think we'll hit it really quick. I just want to show you, you know, again, for dynamic filtering purposes, right now we're passing all for this scenario. But needless to say, I have a lot of options as far as filter criteria. And again, it becomes very easy to do this. I can mix and match these in terms of saying, for example, I want VLAN 100. It's as easy as adding VLAN 100 in, and then I could equally say I want all of a particular port. Needless to say, some of the stuff on VLAN 100 might be on that same port. And so those overlapping features are handled for you by the intersection mode. And again, I mentioned, in this case, we're replicating data. I wanted to send it off to AppStack just to briefly show you those capabilities as well. AppStack provides a separate interface that shows you kind of constant monitoring of what's going through on that side. And in this case, you can see a real-time dashboard here. We talked about threat insights. This is based on known bad IPs and can kind of demonstrate where some malicious traffic appears to be originating and so forth. And we also talked about fine-tuning filtering. You can see I have a Facebook traffic filter here. And what I'm doing with that is actually just pulling out those applications that match Facebook games or Facebook. And you can see that's a significant subset of the overall traffic. I mentioned PCAP as well. This is where you have the ability to actually set up another filter if you wish and pull off any traffic that you want for troubleshooting purposes. I know this is just a really quick look at it. There's a lot of other features here in terms of SSL. Tim talked about passive SSL decryption. That's available here as well, and even layer 7 masking and so on.